Chemical thermodynamics. Thermodynamics is a Greek term which means heat power. It's also the study of energy and its transformations. So what's the difference between thermochemistry versus thermodynamics? Thermochemistry is how we observe, measure, and predict energy changes for both physical changes and chemical reactions. A physical change would be maybe a change of state between a solid, liquid, or gas. Thermodynamics is how to predict if a chemical reaction will occur or not. Collision theory. The collision theory is used to explain reaction rates. Atoms, ions, and molecules can form a chemical bond when they collide, provided energy that the particles have enough kinetic energy in order for that reaction to happen. Particles lacking the necessary kinetic energy to react still collide, but simply bounce apart because they don't have enough kinetic energy for them to collide and transform into new molecules. Activation energy is a term used to describe the minimum energy that colliding particles must have in order to react. So for example, in order to get a fire started, you need to strike a match, which is an activation energy. That striking of the match causes that match to flame up, and you can use that match now to start a fire. Factors that affect reaction rates, well, there's 4: temperature, concentration, particle size, and catalyst. So how does temperature affect reaction rates? Well, increasing the temperature increases the number of particles that have enough kinetic energy to react when they collide. Concentration changes, or if you increase the concentration by cramming more particles into a fixed volume, increases the collision frequency. Particle size: the smaller the particle size, the larger the surface area for a given mass of particles. Decreasing particle size will increase the rate of the reaction because there's more surface area for them to react. And a catalyst is a substrate that increases the rate of the reaction without being used up itself in the reaction. So let's define energy. Energy is a big theme in thermochemistry and thermodynamics. So energy is the capacity to do work or to transfer heat. So what is heat? Well, heat is the energy transfer from one object to another because of a difference in temperature. The first law of thermodynamics states that energy is neither created nor destroyed. It can only be transformed. Therefore, energy can change from potential energy to kinetic energy, or exchange between systems and the surroundings. The whole idea here, the key point, is that the total amount of energy in the universe is constant. It doesn't change. The total amount doesn't change, but the types of energy can change between different types and also in between the system and the surroundings. Here's an example of an energy diagram. This is an example of an exothermic energy diagram because as you can see here, here's our activation energy, or the minimum energy to get a reaction started. It's exothermic because this means that the energy is leaving, okay? And the reason why we can see that is because there's actually a drop in energy between the reactants to the products. So where did this drop of energy go? Well, it went out to the surroundings. Conversely, we have an endothermic reaction where we are actually gaining energy. Okay, and when we gain energy, where does energy go? Well, it goes into the products, and this is considered to be endothermic. So taking a look at a more detailed look at an energy diagram, we have, again, this point here is our activation energy, or the energy required to get the reaction started. This right here represents our substrate or our reactants. Here is our product, and the difference is the change in energy between the reactants and the product, and we denote that by using this delta H. Now also another thing to keep in mind is that the difference between this point and this point is the potential energy of the reactants. And obviously the difference between this point and this point is the potential energy of the products. And on this, as we move through time, okay, this is what happens to the reaction. Okay, so this x axis represents time, and it takes time to go from reactants to products, especially since we have to get over this hump. And this point here is called your transition state, where you're actually now overcoming being a reactant to now forming products.